Hey there, my name is Anahi, Durazo, and I'll be presenting my final key activity from Energy and Transformation 2 about inclined planes. We'll start with a brief introduction to the topic. First, the justification. We refer to an inclined plane as a tilted surface, which is considered a simple machine thanks to Galileo Galilei. It allows movement of objects with less force. Galilei stated that in a vacuum, all objects, regardless of size or shape or weight, free fall with the same acceleration. The hypothesis here is that a body with greater mass will reach the ending point of the inclined plane faster than a body with a minor mass. Because it is a hypothesis, it may be incorrect, but that's why we'll prove it right or wrong. Let's begin. In order for this activity to be done, the materials used were a table made out of plastic, a water container made of plastic also, a chair for supporting the table, an iPad for recording, an app called Tracker as a measuring tool, and in this task, the body is meant to slide down the flat surface and reach 1 meter, increasing its velocity every time the weight or mass increases. Therefore, according to the hypothesis, it'll take less time for the body to reach the meter as it increases its mass. For this scenario, the identified variables are determined as mass as the independent variable that goes from 0.5 kilograms to 2.5 kilograms, time as the dependent variable, that is what we'll get, and while our controlling variables will be gravity, which is 9.8 meters per second squared, and at an angle of 35 degrees in this case, and the distance is 1 meter. Here we can observe the interface of the app Tracker with the 0.5 kilogram example. At our left, we can see the chart presenting the results of the time it took to reach the meter, along with its final velocity. The process followed for this activity consists of first using a table that will function as the inclined plane, elevated at an angle of 35 degrees for the object, in this case a water container filled with water at different masses, to slide down alongside the gravitational force. The steps followed were setting the scenario, recording a video for each body with different mass sliding down the tilted surface, and then uploading the videos to the app used named Tracker, that is the tool for measuring and collecting data, marking each movement the body did until it reached 1 meter, then capturing data in charts for a better organization, separating and labeling each chart for analyzing the results and stating if the hypothesis was right or wrong and why. Now we'll proceed with the results presented in charts, separated each mass. First, we'll start analyzing the mass of 0.5 kilograms, which its distance was 1 meter. Its mass was 0.5 kilograms, which is equal to 0.5 liters, as mentioned before. Its weight was 4.9 newtons. Its total time was 0.733 seconds, and its final velocity was 2.468 meters per second. For the second mass, that is 1 kilogram, its data is distance 1 meter, mass 1 kilogram, which is equal to 1 liter, weight 9.8 newtons, its total time was 0.802 seconds, and its final velocity was 2.445 meters per second. For the third mass, its distance was 1 meter, its mass was 1.5 kilogram, which is equal to 1.5 liters. Its weight was 14.7 newtons, its total time was 0.733 seconds, and its final velocity was 2.728 meters per second. For our fourth mass, its data are distance 1 meter, mass 2 kilograms, which is equal to 2 liters. Its weight was 19.6 newtons, its total time was 0.833 seconds, and its final velocity was 167 meters per second. For our fifth and final mass, its data are distance 1 meter, mass 2.5 kilogram, which is equal to 2.5 liters. Its weight was 24.5 newtons, its total time was 0.768 seconds, and its final velocity was 2.521 meters per second. Here we can see that the results disagree with the hypothesis stated, since the time it took most of the bodies to reach the meter is very close in number between each other. Therefore, it can be concluded that the hypothesis stated was incorrect. As Galileo Galilei said, all objects, regardless of size or shape or weight, free fall with the same acceleration, which this also affects in inclined planes, meaning that it is possible that by human error, the results were not accurate. To confirm this, as stated by Anne-Marie Pendril, other factors as friction and inertia are proportional to a body's mass, meaning that having different masses does not affect the time it takes each body to reach the meter. Thank you for your attention. Here are my references. Have a great day.